So welcome, thank you very much for coming along. My name's Keith Donaldson. I'm the Director of Business Development for Trihedral UK, working out of our Aberdeen office in Scotland. My background, I've been with the company for 19 years. I joined Trihedral in 2000. Prior to that, I was actually a customer of Trihedral, working in the oil and gas industry with oil and gas OEM, doing subsea control systems. My background is software engineering. I did a degree in computer science at the Robert Gordon University in Aberdeen. So although my role in Trihedral currently is a business development role, I'm quite heavily involved in engineering projects, working with our OEM partners, writing drivers, and supporting our customers. So today we're going to have a look at the advanced diagnostic tools that are shipped with VTScada. So these are the tools that I use on a daily basis. I do often wonder why I'm asked to give this presentation. It's probably because I'm most familiar with these debugging tools, probably because the code I write is rubbish and requires lots of debugging. So I'm very familiar with these tools. Just wanted to run over what this talk is about and what it's not about, just so we've got some clarity. So this talk isn't about looking at the specific problems that you have with your plant or process, because we largely don't know what your plant or process is. We deal with a lot of customers in a lot of different industries. What we are going to be looking at is the tools that we use and that you can use to look at any problems that you might encounter with your systems. When things go wrong, there are quite a lot of diagnostics that we can pull from VTScada that you might not be familiar with. And when you contact technical support, they will often ask for some very specific things. So I'm going to try and give you a little bit of background, a little bit of reasoning and understanding about why they're asking for these things and how it helps to diagnose any system problems. So for the presentation today, I just wanted to run through what I've got set up here. We're going to have quite a lot of tabbing back and forward with screens. I know for some people at the back it might be quite difficult because the font size is quite small, but I've tried to take screenshots and blow them up on the PowerPoint so that you can see the detailed information that I'm trying to convey. So I'm running off of my laptop, which is KDNB, Keith Donaldson Notebook. I have a second virtual machine running on my laptop, which is called KDNB-VM, Keith Donaldson Notebook Virtual Machine. And I'm running a Modbus RTU simulator. So this is the simulator that you may have come across when you're using the scripting courses that Andrew has written. It's available. We have it running in the cloud so that you can actually connect to it. But I'm running it locally on my machine. And I've got a note at the bottom there. I have another server, which doesn't actually exist, but I've included it as part of the demonstration of some of the information that we're looking for. So when you see that, that doesn't exist, but it could potentially be another computer somewhere else. So, first topic I'm going to look at is RPCs. What is an RPC? Well, an RPC in programming terms is a remote procedure call. Okay? It's used to invoke, so that's the call part, a piece of code, that's the procedure part, on a remote computer. That's the remote part. Colloquially, we use that to describe the transfer of data from one VTScada server to another. So as you know, if we're doing a redundant system, we have a SCADA backbone network. This is the network connection that connects the two VTScada servers together. And we will say, well, there's RPC traffic running between those two servers. And that's the transfer of information between the two servers. And there's lots of information that gets transferred. So the example I've used on the screen there is something like a set value. And that procedure is used to assign a number to a variable in a module on the remote computer. And RPC traffic runs both directions. So there's RPC traffic running from the primary server to the backup server, and from the backup server to the primary server. And indeed, no matter how complicated your network or structure, there is RPC traffic running around the whole of that network. So, the next topic to make you aware of are RPC services. So VTScada is actually split into a number of RPC services. And this is used to keep data synchronized across machines, but partitioned into the different services. And these services, you can actually see them in the server list. If you go into the advanced mode in VTScada, you can actually add a server list per service in VTScada. And this is how we form some of our load balancing techniques, where you have one server, which is the server for a bunch of services, and the second server, maybe the backup server, but it is also the primary server for a different set of services. Okay? And you can get quite complicated structures set up, load balancing and failover between machines. So just to give you some example of some of the services that we have in VTScada, so we have the alarm notification service, and we have the configuration service. Every driver instance in VTScada can be its own separate service. So you can assign the primary and backup server lists down to a very specific driver instance within your application. We've got modem manager, network values. Network values service is designed to allow a network value type to be shared across the entire network. So as soon as the variable is set on one machine, it's distributed across to all the servers. And we have a whole bunch of services that are built in under the hood that you really don't need to care about as part of your standard configuration. Time synchronization services and value synchronization services. These are background VTScada core services. Services sync bidirectionally as well, using the RPC traffic. So when a service first starts up, it will contact the current primary server and ask for a list of changes that have occurred whilst it's been unavailable. And that information is then sent over to the client. And then the converse happens, that the client reports any changes that it has that the server hasn't seen, and they're sent back. And then the service comes into started and running as it should be normally. Now knowing all of that, we have a look at RPC Manager. And the RPC Manager is the piece of code in VTScada that is responsible for handling all of this information and making sure that all the services are correctly synchronized and the data is transferring happily between computers. And why would you want to look at this? Well, there may be a situation where you've got a primary server and a backup server, and they're not showing the same information for some reason. We don't know why, okay? It should never happen, but it does occasionally. And it could be for any number of reasons. It could be for a faulty bit of code in an application. It might be for network connectivity failures, any number of reasons. And obviously, this is quite a complicated topic. So how do we help you find out where the problem is? So we use an application called Trace Viewer. Okay, so that's a screenshot of it. We're actually going to run it up just now. It's shipped with VTScada. It's always there, and anybody can run it and look. And what it does is it shows and logs the traffic that is running between the VTScada servers. Now, it's beyond the scope of this presentation to actually decipher and decode what all that traffic means. It is all fully documented. It's in our documentation. But understanding it is very, very difficult because there are lots of parameters and lots of different information. However, this information is also logged to a database. And in the situation that you're having a problem on site, it would be advantageous for our developers to have logs from both ends. And that's very important, and I will repeat that at the end. But both sides of a dual server setup, because the picture that each VTScada server is seeing could be slightly different. And to be able to diagnose this properly, if we have the capture from both ends and we know that the time synchronization is working, we can then see the whole conversation and where things might be going wrong. So let's take a look at the RPC Diagnostics application. So I'm just going to run to my VTScada instance. So there, second from the top, you can see the trace viewer application. And I just click run, and it pops up a fairly blank and innocuous window. Okay. Clicking on the little lightning bolt icon, the first one on the taskbar there, shows a list of things that we can trace and look at. We're going to look at some of these just in a moment, but the one we're interested in is RPC Diagnostics. And if I just click on that and click close, you can now see a bunch of data scrolling by the window. Let me see if I can maximize that just to, for clarity. And there's all sorts of information going on there. I'm going to hit the pause button just up the top, and that just freezes the screen so that we can analyze what some of these things are. And there are a number of columns. So there's a timestamp, which is critical. Obviously, that's recording when the message was sent. The direction, either from this machine or to this machine. The IP address or the name of the other server. And then there's the actual data packet that was sent. And that's a textual representation of the data packet. Typically, it is actually a binary packet. Okay? So all of that data is really very useful. I would like to put a word of caution doing this. Monitoring RPC traffic is quite intensive. There's usually quite a lot of traffic on a busy system. And if you consider that we have hosted solutions where we've got 250,000 RTUs, lots of data passing back and forward between primary and backup servers, lots of internet client traffic, lots of busy things. Turning on RPC Diagnostics could be detrimental to your system because it does take a significant load. And it is also writing this out to the disk. So you do have to use this with a little bit of caution, okay? So I'd like to just put that warning out there just now. Right. The log files are kept in a trace files directory in your VTScada folder, okay? And they're recorded to an access database, an MDB file. Okay, and there's several tables in there. There's lots of things you can do with this data. I'm not going to go into it in excruciating detail, but you can filter it, you can highlight things, you can turn on and off different columns of data. But it is the tool for capturing the inter-VTScada process communications. Okay, there we go. So there are a couple of other things I wanted to look at in this application, because it's not just the data that is viewed when in RPC Diagnostics, in the trace viewer application. What we can also look at are the communication connections, the socket connections, the TCP/IP socket connections between VTScada and the other VTScada servers. Okay, so I'm going to do that just now. We'll just do this live. Again, I'm going to switch back to the RPC Diagnostics application. And that window there is actually the second to last icon on the top bar. It's quite difficult to see. I apologize at the back. And if I just click on that, it pops up a window. And in my current example, there are 3 entries. We'll start at the bottom because it will make more sense doing so. The bottom entry is for my machine, KDNB. So I have a socket connection. I actually have a socket connection to myself. RPC Manager makes a loopback connection so that it actually sends outbound traffic on a broadcast, and the server itself receives that traffic back so that every machine sees all of the data in the correct order. And listed there is the name of my machine, KDNB, and an IP address. But it might not be the IP address that you think it would be. Currently, the IP address I've got there is a 172.20 IP, which I think is an IP address that I'm on the wireless LAN connected to the hotel Wi-Fi network. VTScada is very, very clever at trying to resolve network interfaces. And it does so by running up, interrogating the computer, finding all the network interface cards that are available to it, and trying to monitor any inbound RPC traffic connections that are made to that. Okay. The reason it does this is VTScada is capable of doing what we call multi-homed networks. And that's where you have multiple network cards installed in the server. And you can do redundant network communications between VTScada servers. So you may have two paths to connect from one VTScada server to another. And if one fails, it will automatically fail over to the other one. So VTScada will go out, search, and try and resolve every network interface that it can find on that machine. If I expand this little drop list there, it gives me some basic statistics about what's going on that socket connection. And on that particular one, there's something called a execs count. And that's a number of executions of RPC messages that have occurred on that particular socket connection. Currently sitting about 4,400. Not doing very much traffic on here. Having a look at the second item up, I have KDNB VM. So now that's the socket connection of the server that I'm connected to. And this is, and we have to be careful here, this is my server's view of the VTScada socket connections that my server knows about. The other server may have a different view of the world, okay? But it's reporting back that it's on an IP address 192.168.56.1. So that's the default IP address that's been assigned to my virtual machine running VTScada. And again, if I drop there, there is another set of diagnostics that is displayed. And there's this second line. And what that shows is the socket that the KDNB VM VTScada is using to connect back to KDNB server. If that makes sense. And you can see the number of acknowledgements. There's to and from diagnostics, how many messages have been sent, how many have been received. There's some basic counts in there. But this can be really useful if you have, there's a disconnects column there, disk, D-I-S-C. And if that number is incrementing high, that means there's been a lot of dropped connections between the two VTScada servers. And that can indicate that you have a communications problem between the two machines. So we have seen situations where traffic is being lost, updates are not being sent through, and it's been a case of there's been a faulty switch that's not in the network path between these two servers, and packets have been going missing, they've been dropped on the network. And it's in this dialog box here that you would see some of the diagnostics. Again, beyond the scope of this presentation to go into the details of exactly what all of these are, the purpose of this presentation is to make you aware that these diagnostics exist, and you will be guided to them by the developers and support team to gather the information. Okay. Just going to jump back to the PowerPoint and move on to the next slide. So again, something else we can look at in RPC Diagnostics application is the status of all the services that we spoke about earlier, and who is meant to be in charge of which service and what state they're currently running in. So I'll show you that on the live system. Back to RPC Diagnostics, I'm just going to close this particular window and open, and it's the third icon in from the right-hand side that we're interested here, and that's the Services tab. And when I pop that open, it presents a scroll list of all the services that are running for this particular application. Okay, so you can see there are quite a few there. My application is called Advanced Diagnostics. So everything associated with that application is preceded by Advanced Diagnostics / and then the name of the service. So in this particular one, if I look at the modem manager, for example, it's saying that server is KDNB, as you might expect. And then if I expand that, it shows current status, so I am the server. Server mode, that's an internal mode variable. Mode typically means one of several modes of operation of the service. And there are lots of different complexities to services. For example, we have sticky services, where if a server fails, the service will move over to the next available highest order server on that list. When the primary server comes back up, what happens? Okay, so we can configure it so that the service goes back to the highest order available server, so that would be the original machine. Or we can configure the system for the service to remain failed over onto the backup server. And then if the backup server should fail, it will then jump back and reevaluate the ordered list. So the mode, it just gives you an indication of these things. And there's some further statistics there. But what's really interesting is it also lists all the other servers that it knows about for that service. At the bottom, we've got ourselves, KDNB, the IP address, type is local. So this is a local server. It's telling us it's on machine. And it's saying the state is local, it's running. It is, in fact, the server. And some other little statistics there. Is it connected? Is it synchronized? The unique session ID. Again, some internal variables. Looking at KDNB VM, I can see that the modem manager service on that machine is type remote. So it's not running on this machine. It's running on a remote server. But it isn't state ready. It is actually waiting to take over should the primary server, should KDNB fail for any reason. Okay? And then because I have added another server, that's the title of the server, into our server list for the application, even though it doesn't exist, VTScada is trying to connect to that server and gather diagnostics for it. So it's saying in there, machine pending, and if I expand that, it actually says it's a failed session ID. It can't establish a connection to that machine. Okay? And all of that information is available for all of the services that exist within VTScada. Okay? So at any one time, you can go in there and find out exactly the state of the entire system. Okay. Can I just have a quick show of hands? How many of you are running on multi-server systems, VTScada multi-server systems? Okay, that's great. Good. So, sticking with the Trace Viewer application, one of the other things that we can do, instead of looking at the RPC diagnostics, is we can actually trace the communications between VTScada and your remote devices through the drivers. So we can actually start tracing the driver traffic. And to do this, we go back to our yellow Thunderbolt icon. I'm going to stop tracing RPC Diagnostics just to give us a bit of a clean screen. And I'm going to trace the RTU simulators Modbus traffic. So I'm going to select the driver trace for RTU simulator. Okay. Now, usually when you do this, it would pop up a blank screen, but I was checking my presentation earlier this morning, so I've got data that's displayed on the screen there. but usually you'd be presented with a blank screen. And you have to go into the second icon from the right and select which instance of the driver you would like to gather driver diagnostics from. Okay, and you can expand it out, and it lists all of the things. I'm just going to select all of the information here. And you'll see that we suddenly start tracing Modbus communications. So if I show you my application, it's just a nice, simple little application. It's got 5 Modbus registers, 6 Modbus registers that we're reading from the RTU simulator, and the data is changing. If I go back to the driver trace, you can actually see the Modbus traffic. So if I just pause that once again, you're getting similar sorts of information. So you have a timestamp, the direction that the message was going, whether it was being sent to or from the server. You have the IP address of the machine, destination port number, destination driver, and then the data itself in an ASCII representation of the data that's on the wire. Again, this information is actually being recorded to a database. Again, once again, in the driver trace files directory in VTScada, in the VTScada directory. So you can actually leave this running in the background, albeit the same warnings apply that there is a bit of a service hit on recording that data, but it will log continuously that data to the database. So if you're having problems with particular site communications, you can set up the driver diagnostics to record the traffic and actually see over a period of time what's going on. Now, to be clear, this is VTScada's view of the traffic and not exactly what's on the wire. And there is a difference about that. If you were using something like Wireshark to do packet capture, you're capturing the actual data that's on the wire, whereas this is the VTScada interpreted version of the data that it sees. And that in itself can actually be useful if there is a problem with the driver or the configuration that's misinterpreting the data. You can compare the data on the wire with the VTScada's view of the data and see. Yes, you have a question up the back.
Will you pause the app here?
Yes.
Does it pause the writing to the database?
No, it has not. So what you probably can't see up there, because it really is very, very small, is down the bottom, there is a number of records count, which is on the bottom footer of the display, and it is currently incrementing up. So the pause button there is simply to pause the scrolling of the display so that you can look at what's on. So the display and the data capture are actually separate items. And we can actually quit the application, and we get a warning that says, the driver trace for RT simulator is still being logged. Do you want to continue logging? And if you say yes, the application will quit, but in the background, it's still going to be recording that data to the database, okay? And of course, that means that your log file is getting bigger and bigger and bigger as well. So if you have a lot of traffic on a busy system, you should be very careful about leaving logging turned on. That could obviously be detrimental to your system. Okay, I'm going to say no and quit that application because we're going to move on to the next application. So, again, shipped with VTScada is an application called RPC Timings. Now, you've probably never heard of that. You've probably never seen it. But it is installed with all the debug tools. So in the installer, if you take install debug tools, you get all of these tools installed. They just don't get added to the application manager by default. So they're in the directory. You just go in there and add them in. And the RPC Timings queries the VTScada RPC manager to retrieve statistics about how well it is processing data through RPC manager. Okay? And this can be incredibly useful if you have multiple servers and you have different latencies or different bandwidth links between your servers. This will allow you to see exactly how the system is performing and to be able to tune VTScada to handle these network conditions. Okay, so what I will do is I'll show you the application running. It's a little pointless just because I have 2 servers and they're on machines, so you would hope that the queues would be processing extremely quickly. But on a larger system, this can be useful. So I've already added RPC Timings to the application manager. I'm just going to remove it just to show, yes, I want to keep this. So to add it in, you would simply just click on the Add Applications, go to the Advanced, say you want to find an existing application that's been installed, and then from there you'll see a list of various applications, one of which is the RPC Timings, and you click Next, click Finished, and RPC Timings is added to the application manager. Running it up displays a grid list view. It's a very, very simple application. If I just press the play button, it will fire off an RPC query to VTScada, to the RPC manager, and monitor how long it's going to process and round trip. So what we've got here is the first column is the machine name. So this is fired a message to KDNB VM. It said the IP address is 192.168.56.3. There was an 11 millisecond queue delay. That was that it took the message 11 milliseconds before it was transmitted. So there was obviously other traffic sitting there waiting to be sent before our message got sent. And then it does a series, I think it's 5 or 10 messages. So the average queue delay was 4 milliseconds. The best was 2 milliseconds, and the worst was 19 milliseconds. Okay? And the last column is the link tolerance value. And I'll come back to that in just 1 second. There is a second row for another server, but we've not managed to gather any diagnostics for that trip because it couldn't contact another server because it doesn't exist. But you can see that running on a busy distributed system, you can very quickly build up a picture of how your network is performing and how quickly VTScada is able to get data from one server to the next. We have had situations where there has been slow network connections between servers, and the queues, the RPC traffic queues, build up. And it becomes a significant period of time before the traffic can actually drain down. And this can be particularly bad when the historians are resynchronizing lots and lots of historic data. Now, it does do this in a low priority background task, but obviously it does have some detrimental impact on the networking performance. So it's a good idea to run this application and just view the data and see the timings that are involved. And it's also good to run this at both ends of your link, from both servers, and just make sure that one server's view matches the other server's view in that. So the link tolerance column, that's an interesting one. We don't see its use very often, but you can tune VTScada to say that a particular link on RPC is slow. And you can increase the tolerance on that, so it actually slows down the traffic processed through that particular link. So we used to see it more when there were wide area networks and we didn't have high-speed fiber, and it was more like ADSL or copper or PSTN dial-up connections between 2 servers, and traffic would really back up. So if you had a primary and a backup locally with a Cat5 network connection, and then a third server that was at the end of an ADSL connection, you could put the link tolerance on the ADSL connection up, and that would just allow a bit more leeway on that before it started dropping packets there and then losing missed data. This is fully documented in the help files, exactly how you do that. You have to edit the setup.ini file, which is in the VTScada directory, and that requires a VTScada restart to get that to reload again. And you name it under the link tolerance section. You list the connection and the tolerance value you want in there. So the last column in the application just shows you the tolerance value that's been set on that particular link if you've been tuning it. Okay. Going to move on. Another application that ships with VTScada that isn't added to the application manager by default is the trace VTScada actions. This is essentially where the developers write lots of log messages about things that are happening within VTScada. So it's not something that you can write code to write to. This is very much part of VTScada's diagnostic logs. So I'm going to just go and run that to let you see. Again, I already have it added under trace VTScada actions. If I run it up, you'll see, I'll just expand that a bit more, a whole bunch of things. So just quickly run through what it is. The main window itself is the textual description of the log messages that are being put into the file. Up the top, there is a start button, which allows us to trace to a file as opposed to just keeping the logs in memory. We can erase the file. And then there are a number of tick boxes that allow us to select which of the VTScada components we would like to log in there. So some options are the application manager itself. So that's adding and removing applications to the VAM. We can trace the display manager, menu editor, modem manager, any HTTP requests coming into the internal HTTP server that VTScada has, expression manager, configuration manager, RPC itself, and that's the RPC manager. So when it's doing work and actions, it can actually log data in there. So you can enable and disable different tick boxes. And then the messages, there are lots of things. So for example, the date and timestamp that VTScada started tracing. Okay, what we've got, it traced new machine node, instantiating a new machine node by the name of KDNB, and then that's in the system network manager machine add module, and so on. And again, you're not really going to be interested in the contents of this file, but the developers, if something's going wrong, really are, and they'll be able to help you out by looking at what's been reported in here. So again, the purpose of explaining this to you today is to make you aware that this exists, and you will be guided to that and what information they would require from you in order to help diagnose any particular problems you might be having. Okay, I think I've said on the slide that there are two files. When you start logging to disk, VTStrace.txt is the one that contains only the items that you've selected on those tick boxes. And there is a second file, which is VTScadaTraceAll.txt, which, as the name suggests, is tracing all of the items regardless whether you have them selected or not. It's a bigger file, so that's the reason that they tend to do that. Last two things, there are a couple of edit boxes there. Records in RAM is the number of records that we devote to keeping in memory before it gets flushed out to disk. There's a trade-off here between using memory that might be available for your application versus losing those log records if the server should crash for any particular reason. So a bit of a trade-off there. And a parameter byte limit. So some of the messages that we log here can be pretty big themselves in a single line. So we just limit the number of parameters. Sometimes we're just not interested in the actual content body of the message. We're interested in the fact that it's been called and maybe the first couple of parameters. So this was one that Greg pointed out to me yesterday. So I don't really get involved in using Twilio, but I was chatting with Greg about the different diagnostics, and he was pointing out that Twilio service in VTScada writes its own separate logs. And they're extremely helpful in trying to understand what's going on with Twilio. Should there be a problem with your callouts alarm notification? And so they're held in the data directory of your application under Twilio logs, and they're a rolling timestamp log, and they're held in JSON format. And there's a whole bunch of information there. I just selected one record there just for it and things. So it's various URLs, callbacks, statuses, and the whole interaction with the Twilio service. So I guess if things are going wrong and you end up speaking with Greg or tech support with regards to Twilio, grabbing these logs and sending them in will almost certainly be required to find out exactly what's going on in your system. So I mentioned it almost in passing, but probably worth knowing that they exist. So the next part of the presentation is really going to be on the Source Debugger. Just a quick show of hands, how many of you have used the Source Debugger before? So some of you, okay, good, excellent. So I'm hoping that I've got some information in here that's useful for you too. I'm going to run over the basics of the Source Debugger. For those of you who haven't used the Source Debugger, again, it's a kind of advanced topic. If you're just using or configuring VTScada, you shouldn't really need to use the Source Debugger. But if you're doing any sort of code development to any sort of level, so if you're doing any scripting, I can't imagine you not using the Source Debugger. And as I say, I use it almost on a daily basis. But there are a couple of features in here that are worth looking at as well, even for people who are maintaining systems. With all of these things, we're probably giving you a lot of rope to hang yourself by showing you all these advanced features. But knowing about them, I think, is really useful to just understand what's going on. So advanced users only, it's complex but useful. Okay, so I've broken down, I'm going to jump between the Source Debugger live window application and the slides, only because I've done these little screenshots to try and pull the information out so that people at the back can see properly. So there'll be a little bit of jumping back and forward. The Source Debugger is, again, shipped with VTScada. It is added to the application manager by default if you select the debug tools. It's usually the first one in the list. I'm just going to run the Source Debugger. And this is what you're displayed with. I'll maximize the window there. So it's a bit of a monster application, actually. So the first thing to look at is the System Summary tab. Very useful. Tells me what operating system I'm running. Okay, so you've got to think, well, surely that's kind of obvious. Well, we're dealing with lots of customers running lots of different operating systems, and sometimes they lock down the operating system, so we can't actually get to it. We can only run VTScada applications on the console. You have no access to any of the operating systems, so it's sometimes very difficult to actually know. And when dealing with complex problems where the developers are debugging, knowing the operating system is critical. It absolutely is critical, including which service packs and so on, which bitness, if it's 32 or 64-bit. That's all really critical information. So it's put right there on the top line. The second bit has a little drop arrow, and I'll expand that. I'm going to flip back to the page, and it just shows you in a bit more detail what's going on. So VTScada info, it shows the current amount of memory that VTScada is using. So as you'll know, VTScada likes memory. We try and keep everything loaded into memory. So we do keep a close eye on that. We're going to look at memory leaks and memory leak detection shortly, but looking at that over a period of time will give you some indication about just how much VTScada is using. And then we have different bits about the version of VTScada that is in use. at this point in time. So we've got the version, if it's 64 or 32-bit, what serial number it is. I'm running serial number 1. A full license type. So that depends whether it's a runtime, a light version, or so on. When my updates expire on the 16th of July, 2100. Wow, okay. I've got unlimited number of tags. I've got an unlimited number of browser clients. I have alarm notification enabled and just a grab of the memory that's used. So nice little summary of what's happening in this system. And then we drop down to the next part of the thing, threads. So I'm just going to expand that there. And show you. So threads are, for anyone who doesn't know, are bits of code that are running concurrently together. So if we want to run a piece of code alongside another piece of code, and we time slice between them, then we launch off a thread. And currently I have 35 threads running in my VTScada application. If I pop open the window, so the little blue icon there allows me to pop open the thread view into its own window. I can list all of the different threads. And what I'm going to do is just turn on, there's an icon, a little refresh icon there. If I toggle that and pop back to my view, you can actually see a live process update of exactly what's going on in my system at the moment. So it's showing you all the different threads that are running. And the columns across that are thread ID, so the unique thread ID within the system that's assigned by the operating system, what the status is. So for the most, they're in an idle state because they're doing something and then coming back, and it's doing it so quickly that it is just showing as idle. But it shows you the last module that was executed, the last state that was executed, and the last statement that was executed. And you can see that that's live refreshing at the moment, okay? And from our application, I can actually launch off a thread by clicking on that button. If I now go back to my thread list, you can see we've got a new thread on the bottom called mythread0. Just the name of the thread. Now, in fact, I can launch off 2 or 3 different threads, and they're just launching. So for those of you who have done the scripting course, when you launch a module, one of the things you can choose to do is actually launch that onto a brand new thread. And it allows it to concurrently run alongside all other VTScada script, regardless of what's happening. Okay. I can also kill off threads in my application. So I can press that a few times, and my threads should have disappeared. So threads come into existence and they get slain. And there are lots of different threads. VTScada runs one thread for every application that's in the application manager, for example. That's looking for people importing changes and so on. And then VTScada itself has several main threads. So there's a main application thread where most of the code is running. There's the display manager thread. That's where all the display rendering happens. So there are a few different threads running within VTScada. They're all listed there. Right, close that. Execution history. So this is kind of neat. I'm going to close this window and open the next one. I'll pop it open to its own window again just because it's, I think, a little easier to see. But what this shows us is the last, in this particular example, 10,000 statements that VTScada has executed across all of the different threads. I can limit that to various different threads, but at the moment we're looking at all threads. What were the last 10,000 things VTScada did? Okay, And again, I was teaching a scripting course earlier in the week. I see a few familiar faces. One of the things I said was, you can never really tell which order of execution VTScada is going to execute statements that are in a steady state. But actually, that window there shows you exactly that. Okay? We can't maybe predict what it's doing, but we can view what has actually happened. So this is useful in a post-mortem debugging, and we'll touch on that slightly later on. What's neat about this is if I double-click on any particular statement, it would take me to the piece of source code if I had the source code installed. So unfortunately, that module is VTScada, a VTScada module, and I don't have the source code installed on my machine for that. But if you're debugging an application and we found an application execution and we clicked on it, it would take us right to the source code point of that execution. So a neat way to navigate around the application. So we can limit which thread we're showing. So I can have a look at, let me have a look at our advanced diagnostics thread and hit the update filter. And we can see various different broadcast manager. There's VTS read. So that's part of the driver. The Modbus driver is actually doing the read there, so I can see things that are going on. And you know, you can see just how busy the system is. And that capture was less than a second. That was about 400 milliseconds capture, and all those statements executed in that time. So busy, busy system. Statement numbering. So when looking at some of these windows, VTScada shows you a main, state, and a statement number. And I wanted to touch on that because when you're writing these script code, it's actually quite difficult to figure out what the numbering or how the numbering works. So what I'll do is show you, if we go into advanced diagnostics, so I'm going to debug our application and show you a quick tip to quickly navigate. I want to debug this page here. So if I use the arrow, which is the fifth icon in from the left at the top, and select that, and then click onto my page, VTScada will move me as close to that module as it possibly can. At this point, it's actually in the display manager, and I'm just going to navigate in to my page. So this is now showing me the source code for my page. Okay, I'm now starting to look into my application. And VTScada will number the statements in the currently running module from 0, 1, 2. Okay, that seems fairly straightforward. And what it does is it runs through all of the statements in steady state and then goes back up and starts running through the scripts in the order that it finds. So numbers suddenly get out of sequence. But there is a very easy trick to figure out which particular statement you're looking at, and that is if you place a breakpoint. So I'm going to place a breakpoint. This is something we're going to look at. And to do that, I can just pick any particular line of code. So I'm going to scroll down here, and let's have a look and see. I'm going to put a breakpoint on my thread launch. So I click this button here, this black button in the middle of the toolbar, and that places a breakpoint. You can see a couple of things have happened. Got a little breakpoint icon on the side of the line of code that I placed it. A breakpoint has appeared in the breakpoint window. But usefully, it's actually come up and told me that it's statement number 222 on my page. So I can immediately find out what statement it is. Okay? So that's really useful if you're going through your thread history execution and you need to figure out, oh, I'm not sure which statement exactly that is. You can place a breakpoint and it'll tell you exactly which number it's on. I'm going to go back and look at the high resolution profiler. So that's back on the summary tab here. and it's down the bottom. So the reason that we call it the high resolution profiler is that last year when I demoed this, this was a development feature that hadn't been released in the product. Now this year it has been released and it's available for you all to use. The profiler allows us to gather diagnostics about how well VTScada is functioning, how many executions are occurring in our application. Okay. This is best done by a little demonstration. So I'm going to run the profiler for 5 seconds. So I click the play button. There's a duration. You can see it's set up for 5 seconds, then I'm going to stop. And it gives me a list of everything that's executing at the moment. And it can tell me that there were 77 window repaints occurred during that 5 seconds of VTScada. So the engine spent, how much time there? 239.4 milliseconds painting the window during that. So that's great, that's good news. And then the script threads. So I can expand that and see there's a list of everything that VTScada did during that 5 seconds. It shows me all the executions and how long it spent in any one of the bits of code it was executing. So where does this become useful? Well, it's kind of interesting, but where does it become useful? So I'm sure you've all heard of the if-one condition. Again, I spoke about it at the script course. This is a condition in VTScada where you do if true, and you get caught in an execution loop where VTScada is just simply burning the CPU, executing around that loop just as fast as it can. So let me show you what happens when you do that. I've got a sample here. So if I click on this button here, if1, it's going to do it. Now, you'll notice that the Modbus comms has suddenly slowed right down. The temperature of my laptop is going to increase significantly. The fan in my laptop will probably start running. If I have a look at my task manager, we can see that the VTScada task is currently running 21%. But that's 21% of the 8 CPU cores that I'm running. So it's really going to the wall, executing code. If I show on the Performance tab, you'll see that they've all taken a jump up. You can actually see where I started that. If I go back to the profiler and just do another profile for 5 seconds, okay, it's not very obvious. I can drill down, but I can see that there's something taking a lot of time. The overview main page, there's only 2 counts of something, but it took 4,168 milliseconds there of everything. It's quite high. And if I drill down into that, I should be able to drill down. So we're working down the module tree. And then there are various, busy subroutine seems to be a bit of a culprit. If you keep drilling down, I can see that there were 239 million executions of statement in there. So that's a bit of a clue. But drilling down through this tree seems a bit of a chore. So the guys have usefully added a flip tree, which will sort things from the leaf nodes up based on the number of executions. So if I just click on that, you'll see that based on total time, we've got the overview, busy subroutine, and my busy subroutine is actually embedded in my overview page, so that's why it's showing, and it shows every execution down. So it allows us to hone in on inefficient code, things that are taking a long time. And you can actually set the profiler up to run on timed execution, so you can do this time and time and time again, store the results, and it'll do some comparisons. So you can deploy code, make sure that your system isn't degraded based on new code, make sure that it is still running efficiently. I'm going to stop my F1, let my processor recover. So you can see all the process graphs dropping off there. To the side of the Source Debugger, you may have noticed these trees. I'm going to just turn off code coverage for a moment, as we'll look at that momentarily. And you can see that there are this tree of modules. And the tree has 3 tabs on the bottom. There are static, scope, and call trees. And just going to touch on each of those in turn. So the static tree lists all of the source code modules in VTScada and your application as they are declared in the code. Okay? And we usually sort it alphabetically, just so that it's nice and easy for you to find. So you sort it alphabetically using the icon up the top there. The scope tree shows the same module lists, but based on how the scope resolution is working. Okay, and that's the that there shows the location of where those modules were launched into. Okay, so if you're doing an implicit launch, so that's calling a module from a script or launching a module from a script, then those modules just get launched into the parent. If you're using the launch statement, like VTScada does for launching its tags, then the scope tree can be very different. So I have an example on my page here, the overview page, and I have a grandparent module, and the grandparent module is launching 2 parents and a child. And you can see here that I've set the parent to be self for mum and dad, and then baby is launched into the mum parent. And you can see that that in fact is how we do that. Mummy shark is there, and baby shark under mummy shark. So, yeah, now that song's stuck in your head for the rest of the day, I'm sorry. The call tree, on the other hand, and as you might expect, shows you the same module tree, but listed or ordered by the caller. So who called that module? So again, just looking at the reference that we have here, I have my grandparent module, and the grandparent actually launches the child and the 2 parents. So all of those modules are grouped underneath the grandparent. So it's 3 views on the same module list. It's just designed to be able to help you figure out and navigate the tree. Most often than not, the scope tree is the one that you're looking at because that's where you're resolving your variables as you're looking up the scope tree. And whereas the call tree is most useful to see the lifetime of the module. So if the parent of the child module goes away, then obviously the child module is destroyed as well. So different views for different things. Next is the variable window. So I'll just show you this up here. I'll leave this on display because it's nice and big. A couple of things just to show you there. So we have the module name that you're running in. So in this case, overview. We have the state that the module is currently in at the moment, the number of instances of that particular module, what the return value is. So in this case, because the text is in blue, we know that that's an object value. So it's returning back the object value of the page itself. A filter to help you order the list below to search for different variables. And then you have the variables themselves, the values. There's a little icon here that allows you to change the view of a particular variable. So if, for example, this text string, if we were to click on that, it would pop open a window with the bytes of the text string as well as the text string itself. If this was an array, you pop open the window, it would show you all the elements of the array, and so on. Scroll list, obviously, to scroll up and down. The count of the number of variables that exist in this particular module. And then there are 4 tabs along the bottom: local, instance, auto, and global. Quickly run over those. So local variables are variables that exist within the module as it is. So you can see here, I'm in the grandparent module, and I have name, which is the parameter, mum, dad, and baby, which happen to be the object references to the launched modules that we had. Okay. If I click on the Instance tab, there are no instance variables. Instance variables, they're very rarely used, but just to cover off for completeness, when VTScada creates a child tag, for example, when you create a child tag, a reference is temporarily added to the parent of that module, and only that instance of the module, so not for every instance of the module. So if you were debugging instance variables, you would see them listed there. It's not used very often, certainly in day-to-day use of VTScada. The Auto tab is really handy. What the Auto tab does is it looks for the current line that is highlighted in the source code and lists the variables on the couple of lines above and a couple of lines below. So if you're debugging a big module, let's jump back to my overview page. And there are a lot of variables in there. If I find a script and click on that line of code, it shows me the variable in the line above, the variable in the line I've selected, and the variable in the line below. So it's just a quick way of finding or narrowing down your variables. Conversely, if I click on the Global tab, that will list all of the variables of this module and my parent's module and my parent's module all the way up the scope tree. And you can see that I've got, in this particular instance, 18,143 variables to play with. Okay? But if you're trying to reference a variable, it's a good way of being able to find it and then filter to make sure that you're looking at the correct variable instance. Breakpoints. Let me just double check the time. Okay. So breakpoints, very, very useful. Again, I'm going to throw a warning out here. We're giving you some more rope. Breakpoints are used to stop the execution of code to allow you to examine the code and debug and analyze it. Okay? By its very nature, it is stopping the execution of your code. Everything on that thread will stop. If you're debugging on the display manager, all your displays will stop. The clock will stop updating. All your graphics and everything will stop updating. If you happen to be debugging on the application thread, okay, so that's maybe in a driver or in a data point, everything in the application thread will stop. That is all of your drivers, your inter-machine communications with other servers, or if you've got a watchdog, for example, we've got systems with hardware watchdogs, it will stop updating the hardware watchdog. It will think the system has frozen solid and do whatever actions, usually reboot the computer. So you have to be very, very careful placing a breakpoint, especially on a production system, okay? So warning, okay? So to place a breakpoint, you simply highlight the line of code and select the icon in the top of the toolbar there, the black circle. It pops a little orange circle to the side of the line of code, and it lists the breakpoint down there in the breakpoints window. So when VTScada hits that point, I'll just click my F1 button It automatically brings the source debugger to the forefront, and it stops execution at that point. And we can start to inspect the variables. So if I click on auto, for example, I can see the variables above and below. I can then start to single step through the code. And I can do that by using the command step into or step over. Clicking that will advance the cursor, and then it will move. It'll execute the next line of code. If I step into and I encounter a subroutine, the breakpoint will jump into that subroutine and we'll start debugging the subroutine. So I can do that here, my not busy subroutine. And it goes in and I can step, it hits a return value, then execution returns back to where I was. If I want to step over that, so I don't want to go in and debug the subroutine, I'm still wanting to see the execution code of the caller, I do step over, and it will just execute the subroutine and then carry on. So that's debugging and set points. One nice thing you can do with a set point is to disable it. So that is, you leave it in place, but you disable it so it doesn't actually hit. And there's a reason for that's really handy. And so if you do that using the half and half circle up the top next to the breakpoint icon, and if you do that and let it run, let me just place another breakpoint elsewhere in the file. So I'll just place a breakpoint down here, for example. Do the same thing because it's going to hit it. I can now use this as a bookmarking mechanism. When you double click on a breakpoint, the code automatically jumps to that line of code. So quite often when I'm working on 2 or 3 areas of code, I'll place a breakpoint there, disable it, and then use it as a quick reference to be able to jump back to that bit of code as I'm debugging it. One other thing you can do with breakpoints is place what we call a conditional breakpoint. And this is extremely handy, slightly complicated, but we'll run into just in the very briefest manner. To do that, you click on the question mark breakpoint on a breakpoint you've already set to turn it into a conditional breakpoint. And I'm going to tick the tick box there and say it is a conditional breakpoint. And what happens when I do that is it pops up this edit field on the bottom line of the window here. And in there, I can write an expression, and you're all familiar with expressions in VTScada expression editor. It's the same deal here, an expression that when it returns true will trigger the breakpoint. Okay, so if I'm doing something repetitively all the time, so I'm in a while loop here, and I don't want to wait 50 or 100 or 200 or 20,000 times through the breakpoint until I get to the one that I want to see. You can set a conditional breakpoint. So to do that, I have to prefix the variable with a backslash. So I'm going to do k equals, and I want to break when k equals 50. Okay, so I put a breakpoint on k, and I'm saying I want to break when k equals 50. So at the moment, I'm frozen on that line. I'm going to hit the OK button. I'm going to let the breakpoint run. You'll see at the moment k, the value is 85. And when I let it run, it should go. And now it's stopped. So it executed 85, 84, 83, 82, all the way down until it hit the condition that I had set. And then it's frozen again. So now I can carry on debugging from that point onwards. So it's a really neat trick to be able to get into this. Right. I'm going to go on to the last topic before we break for lunch today, and that is crash dumps or dump files. These are incredibly useful. What they do, originally, the history behind these was Dr. Watson which was an application that shipped with Windows NT. Some of you guys might remember that. It used to run in the background, and if a process crashed in Windows, it would take the contents of memory and write it out to a file on disk so that a developer could then come along, try and figure out what was broken with that. And Trihedral was no different. We did that with VTS back in the day, and then VTScada. The term crash dump is used a lot, but it isn't always when the system crashes that you can do this. In fact, you can cause this dump tool to run at any point. Again, warning, what we're about to do is dangerous. If you do this in a live production system, the system will freeze for the duration of the time that the crash dump is being created. And if you're on a large system with a lot of memory, then that might take some time, and it could be tens of seconds, which in computing time is a huge amount of time, during which time your comms will stop, communications with other servers will stop, the screen will stop updating, all of these things will happen, okay? So doing this in a production system, you really do have to, again, be careful. The way you take a crash dump or thing is up here on the toolbar, and the icons are, they look like little barrels with arrows going up and arrows going down. And we're going to do the arrow going down. We're going to create a dump file. So I click on that, and it asks for a location. So I'm just going to put it on my desktop here and give it a name, crash dump 1, and click save. And you'll see that the cursor turns to busy and spinning there as it goes ahead and writes out this dump. And that's it finished now. So you can see that was a little bit of time. If I have a look on my desktop, hopefully date modified, there's the file, just short of a gig in size. It's quite big. It's taken the entire memory, everything, all the applications that I was running at that time, so including my RTU simulator, and dumped it out to a file. Everything is now stored in that disk, a snapshot of the thing. Great. We will request this all the time if you're having a difficult problem and we can't access your system. I'm seeing nodding heads in the audience here. We've probably already asked you for these things. First thing to say is these compress very, very well. So you zip them, okay? You get about a third to a half compression ratio, which is good. And we typically look for these to be uploaded to our FTP site so that our developers can do it. Show you what our developers do with it. Let me just quit everything. So I'm going to quit the Source Debugger. I'm going to stop my application. I'm going to go back to here. I'm also going to stop my RTU simulator. And that's it. Okay, so I now have nothing running, no VTScada applications running at all. I'm going to run up the Source Debugger and open the dump file. Point it there. So we're now loading that image from disk back into memory. And it takes a little minute because it's got a loaded gig file, so it's quite big. When it's complete, you can see that it actually shows me everything that was running. So we've got a new tab, I should say. It says summary for the dump file. It shows me everything that was running at that time. So I was running the system library, which is VTScada itself. It was running the RTU simulator, the advanced diagnostics application, and the Source Debugger. Okay. But it also, crucially, includes all of the summary information that we saw at the beginning. And if I expand that, it shows all the license information for that server that was running at the time. So if I click onto the advanced diagnostics application, and again, this does take a little minute because it has to parse through the file, but it's now going to load that entire application into memory and allow us to page through and see every aspect of the application as it was at the time it was running, including the last 10,000 execution statements. So we know exactly what it was doing at the point that you pressed the dump button, okay? And crucially, you can set your operating system up to take one of these dump files should VTScada crash. Now, here's the thing. VTScada should never crash. That is nirvana. But we're realistic in that we know that there is bugs in software. We have a whole development team adding them all the time. So what we're trying to do is we are really concerned. If VTScada crashes, we really do want to know about it. There's no point in having all these great features and a great product if it's not stable. So we can take these dump files. If the system does crash, we can take these dump files and we can load them in and we can see exactly what was going on at any one time. So I can navigate down to my page, what was called Overview. I just find it in the list here and click on that. And it shows me the source code for the page there. And I can see in busy subroutine, it wasn't running at that point. My grandparent module was running. I can have a look in the overview and see what the value of that variable k was right at the time I took it. It was 0. I was at 137. And we can see exactly what was going on. So we don't always need this when it crashes. If you're having a particular problem, we're able to sometimes see and get state information from driver diagnostics, the state of a particular driver, state of particular tags, or indeed any information at all about the system. If for any reason you don't have the Source Debugger installed, there is another way you can take a crash dump. And that is by going to the Task Manager in Windows, finding the process which is VTS Engine, right-clicking on it, and say Create Dump File. And if I do that, it'll go ahead and do exactly the same thing, okay? But it puts it in the C user's username. Let me just remind myself here. App data local temp. It's not very user-friendly, but it is there, so it's a big dump file. And you probably don't want to be doing this regularly because, as I mentioned, it takes about a gig of size, so you can certainly start using quite a lot of disk space using these dump files. Okay. There is a third way to take the dump file, if you're interested. In the VTScada install directory, there's a dump tools directory, and in there, there's a user dump application. And that's a command line tool that allows you to execute user dump on the process. And it's complex because you have to take the process ID of VTScada and feed it in. But for the programmers amongst you, you might like to use the command line version. Okay. So that concludes the presentation today on some of the advanced diagnostic tools that we use in-house. I'm going to throw open for any questions anybody has. Hi. So, did everybody hear that question? Sorry, the question was, is there a manual way to, if you have services which are configured as a sticky server, so it fails, the server's failed over to the backup server, is there a manual way to kick it back to the primary server? And the answer is no, there isn't at this point. Okay. Any other questions? That's a good question. Actually, I'm going to refrain from answering that for just now. The question was, is there a performance gain by adding multiple network cards to a server? So that's the multi-homed systems, okay? The reason I'm sort of questioning myself on that is typically we round robin across network cards. So we keep all links alive to try and keep traffic flowing through and load balance across those. But there are different ways to configure it. I'm not certain there is a way of bounding together to give you a bigger pipe between the two servers. I would need to check that and see. Great, you all survived. Thank you very much for your attention. I really appreciate it. Thank you.